because you talk about ores, this is about oil. So, when you drill for oil, normally you have a oil reservoir, right? So you're, drilling with a drill bit, something like this. I'm sure the students probably have seen this kind of rig where there's a bit here, where there's some pipe here, steel pipe.
So this you are making a hole to the...
Yes. So here you're going underground, as you can see from this video, right? So you keep drilling, right?
Approximately what depth?
This can go up to about 10,000-15,000 feet.
Oh.
Right? But the problem is, generally, ideally you would have your reservoir somewhere here so you can drill straight.
Yeah.
Okay. But sometimes, let's say your reservoir might be under a mountain. Right? So you cannot actually go here.
Correct.
Or your reservoir could be, this is the sea. It could be
Under the sea.
So you can have a ship here, but maybe it's expensive. So if it's close to the land, you might have to go horizontal, and here too horizontal. Again, you might encounter some obstacle. In this case, you cannot drill any further.
Then take a different
angle. Similarly, sometimes you might have water, oil, and gas. Now you might want to get the gas out, then you might want to get the oil, and then finally the water. So in this case, you might have to again go in a direction, specific direction. Now,
so this is about making the hole or making the drill.
So
making the hole, actually.
Making the hole is easy, right? If it's vertical, you just keep drilling down.
Correct.
But now if you have to go there, now this is only
how do you make a bend?
How do you make a bend, and how do you know which direction you're going?
Yes.
In this case, right? Now, another reason is you might drill lots and lots of wells in one area.
So these are...
Yeah, these are wells.
Okay.
Right? So you might come down, but you, instead of hitting a well, you might have to go in a certain direction. Right? So this is obviously in 3D, if you think about it in 3D. And again, if you hit another well, that's another problem, right? So you need to very accurately maneuver your drill bit to reach that targeted location. And even inside a reservoir might not be perfect like this. It could be going down, it could be something like this, in which case your drill bit has to go up and down to access the reservoir. So what we normally do in this situation is we have accelerometers, but we also have fluxgates. So fluxgate magnetometers are also used when we are doing or performing directional drilling. Now, how we do this? So this is just some pictures of the instrument. So again, it's a little bit like the space boom, but the fluxgate themselves are actually quite small.
Yeah.
But you have to integrate them in these big pipes though when you're going downhole. Now, how we basically do this is, see, if this is your rig, right, and if you know your magnetic north, okay, and then you drill vertically and you start going in a direction of power. Now, at a certain inclination, right? But we cannot see what's going on down hole, right? So let's say this is your drill bit, okay, and this is your magnetic north.
This is on the surface.
Yeah, so this is on the surface. We know we have the magnetic north.
Yes.
But downhole, we don't really know exactly. So we use the fluxgate magnetometers to calculate the magnetic, basically this.
Yeah. So this fluxgate is with the drill or on the surface?
No, fluxgate is downhole.
Okay.
Yeah.
Okay.
It's downhole. So it's constantly measuring the three axes of the magnetic field, Earth's magnetic field, and based on that, working out where magnetic north is.
Okay.
And then based on that, measuring this azimuth, because that's azimuth is where we want to go, right? So here you can see this is the drill bit, this is the tool face angle here, right? And so you're moving the drill bit kind of this way. So the inclination is normally given by your accelerometers.
Okay.
Okay. This is just a equation of that. So
by the way, I have a doubt.
yes,
This Fluxgate magnetometer, we said the external. I mean, while you were discussing,
yes,
or HX, etc. So that is a field that we are measuring.
yes,
So it is sensitive to one specific axis.
correct. Which is why here we have a 3-axis.
So you keep 3 of them.
Okay, yes. So here we actually can't see here,
Mm-hmm.
but normally we have. Well, here you can see. This is in this direction. This is in this direction, and I think there's another one in this direction.
Okay.
And why do we use a flux gate? Why not a surge coil in this case?
Because you want to measure the magnetic field, earth magnetic field.
As DC.
Yeah.
Right. So in this case, you cannot use a surge coil.
Yeah.
You have to use a flux gate magnetometer. Now, see, this angle we talk about here, right? When it's horizontal, when you're vertical, you basically use what? I mean, when you're vertical, you use your flux gate to measure this tool face angle. This one here, right? But when it becomes totally horizontal,
Okay.
then you use accelerometers. You use gravity, right? So here, until 0 and let's say less than 90, you use your flux gates. But if you're going this way, then
Gravities.
yes, because your magnetometers will not.
Yeah.
It will not be able to measure that magnetic field, right? Because it's totally horizontal. So I remember one of the longest. So they drilled, and the longest vertical horizontal well they drilled was close to about 50,000 feet.
Oh.
I think that at the time was the longest horizontal well that was drilled. And of course, there's a
Huge engineering task.
Oh, it is. But I think once you go horizontal, it should make it easier. But then horizontal means you cannot go up and down, because if you go up and down, you might end up in a totally different direction.
Correct.
So again, yeah. This is just an equation. Just show your flux gate magnetometers will help you measure these ones, right? Your HXs, HYs, right? Theta here is obtained with your gravitational components by the accelerometer, and so is phi, right? But X, Y, and Z is found by the flux gate. So again, another example where flux gates, again a niche application, right?
It's actually for navigation, but underneath, under the ground.
Underground, because you cannot see, right?
Yeah.
And from the ground, you see, when imagine something's bent, right? But if you move it this way or this way, it could go in there. You can end up in a totally different direction.
Yeah.
Right? If you're not careful. And again, the angles that the drill string is moved, we're talking about small angles, right? We're not talking about moving it 45 or 50, talking about small, and you build up basically. You build up the angles rather than deciding on one large angle. Yeah, right? So again, flux gates play a key role in this. And the other thing is, I want to add is, in a certain area, you could have 2 wells. Now, you don't want to drill into a well that has already been drilled, or a reservoir, right? But we have these things called ellipses of uncertainty. So the deeper you drill, right,
The uncertainty is increasing.
Right? So your azimuth error and your inclination error kind of increases in something like this, like an ellipse. So a lot of things But again, fluxgates play a very, very important role. Like with submarines, like in space, right? Again, you might think it's just coils, but there's a very important role.